Each input or output modality of human-computer interface has roughly two parts, sensor and some kind of recognizer. For example, in Microsoft Kinect, which brings two modalities, speech and gesture, we have a 4-element microphone array, which with a speech enhancement pipeline forms the voice sensor, and the recognizer in this case is the speech recognition. Let's see some trends in the underlying technologies which enable the progress in human-machine interfaces. The first trend is sensor fusion. While each of the underlying technologies is going to better and better, this is a quantitative improvement and cannot be compared to the qualitative jump each one of those technologies caused when it appeared for the first time. We believe that there is a lot of potential in combining the data from various sensors to bring a new quality. For example, in the first Kinect, the listening beam of the microphone array is controlled by the sound source localizer, which points it to the loudest sound source, even if this is a vacuum cleaner. It is a much better solution to combine the output of the sound source localizer, the phase detector, and the skeletal tracker, and to control the beam with the output of this sensor fusing block. At least we'll point the listening beam towards a human face. And with a little bit studying of the dynamics of the human conversation, we will be able to predict who from the multiple people in front of a Kinect device is going to speak next, and to point the listening beam before that. The second trend is providing better priors and context to the human-machine interface. Subconsciously, humans reflect the gender, age, and the emotional status in the conversation with the other human. The technologies for estimation of the emotion from voice, face, and skeleton are already available, and it is pretty straightforward to retrieve the gender and the age from the human voice. For example, let's say that a voice query for a movie sounds something between Die Hard and Sleepless in Seattle. If it is requested by a 25-year-old male owner of the console with past record of ordering action movies, it is a safe assumption for the human-machine interface to believe that this is Die Hard. On the other hand, if there is a second skeleton and a female voice in the room, it is most probably the more romantic Sleepless in Seattle. The third trend we see is the transition from human-machine interfaces to humans-to-machine interfaces. This means converting the computer into an equal participant in the conversation between multiple humans. For example, if two persons were talking about the nice dinner in an Italian restaurant they had last month, and then one of them asks the computer for a nearby restaurant, a smart response will be, "There is a new Italian restaurant nearby with excellent reviews, do you want directions?" Besides the problems of building such natural user interface per se, there are a lot of technological challenges that have to be overcome. This includes sound source separation, because humans tend to overlap each other, and building a kind of a social layer to detect the connections between different participants in the conversation, because humans tend to talk about multiple topics at the same time. With proliferation of the computing technologies providing new and better quality input modalities, we can expect the human-machine interfaces to mimic more and more the behavior of a real human. Thank you.